Within a new session of Blender, we can now set up our lens distortion and basic compositing. Note that the focus of this video is lens distortion and not compositing. I will leave that topic to the professionals working within that field.
We can delete the render layer since we already rendered out our frame. Right now, single image is the correct option, but once we've rendered the full sequence, we can change it to image sequence. And Ace's CG is also the correct color space since, well, that's the color space we rendered in. By clicking on it while holding Ctrl-Shift, we can set our image as our preview. Press V to make it smaller, Alt V to make it bigger. Let's adjust our render resolution. The resolution of our original backplate was 4096 pixels in width and 2160 in height. Though we set our render resolution to 50% earlier, so the preview render I've done right now is actually at 50% resolution. So let's change that here as well. Of course, you don't have to do that if you intend to render your sequence at the full 4K resolution. Let's work with this pre-composited beauty path for now and only think about the image distortion. Right now, our frame has no image distortion. It is very common to add back in the distortion of the original plate though. So let's do that. In the published directory, you will find this STmaps directory. Let's bring in both the distort and the distort no changes exas. Great. Let's set up our image distortion now. For this, we will need the map UV node. And in addition to that, we will need the RGB curves node. The map UV node technically only needs the red and green channel, though it uses the blue channel as a mask. However, the blue channel is actually completely black, so our whole result is hidden right now. To change that, let's go to the blue channel and just turn everything white. Now we have our image distortion back. However, this distortion image is at the full 4K resolution and upscales the image to that resolution. So if we were to connect our output to the composite node and render now, our image would actually be cropped. To avoid that, we have to downscale our distortion images. This is only necessary if you set your render resolution to 50% as we did earlier. For the taste of some people, this image distortion might be very strong. This is why we brought in the secondary image. It doesn't actually contain any lens distortion data, and by mixing the two together, we can reduce the amount of distortion. You can now use the factor to increase or decrease the lens distortion. You might get these weird artifacts around the edges, though those will be cropped off in the final render. Next, let's bring in our plate. Let's switch over to the movie clip editor so that we can set the correct input color space for our plate. We also have to consider that the backplate is in 4K as well, so we also have to downscale that one. We now have to switch over to the view layer mode instead of the pre-composited mode. After doing that, we have our render passes back. In the combined, we only see our objects, and in the shader view, we would only see our shadows. Since these are separate outputs now, we will need to duplicate our map UV node. To add everything together, we will need one alpha over node and one mix node. While this looks fine already, it's not actually perfect. The issue that we have right now is that we didn't completely distort our render. This would only work without any changes if we only use the distort EXR and not the distort node changes. By the way, we should set our distortion images to raw, though it won't actually make a difference in this case. Raw just means don't convert anything, and right now this was trying to convert from ACG to ACG, so nothing's happening there either. To fully match the two files, we will need to add the undistortion STmaps. We now need to make sure that these two images are combined in the opposite way that the two above were. We can do so by either connecting them the opposite way around or by inverting the factor. Let's also change the scaling methods of the transform nodes to bilinear, as that will give us a smoother result. Great, now there is no more gap in between these two. If we wanted to change the distortion dynamically, we could add a value node to both of the mix nodes. Now, if we change this value, the distortion of our backplate and our CG render will change together. This video is not about compositing itself, and I only wanted to show you how to apply the distortion in Blender, so I will not explain how to improve the compositing itself, but I will quickly show you how to use STmaps in Nuke as well. Just like in Blender, the first step is to import our render. You will notice that we don't see anything. This is because we haven't actually defined which of the passes we want to look at. To do so, we have to create a shuffle node. In the shuffle node, we will simply select the composite combined again, just to see a full preview. At this moment, the colors look very off, so let's change our OCIO settings. To do so, go into the node graph, click and press S, and then go into the color settings. Select OCIO, and as the OCIO config, select ACES 1.1. Great, now the color looks correct. Let's now import our distortion profile. As previously mentioned, it's not necessary to set this to raw, but it's cleaner. Next, we need the STmap node. This is the actual node applying the distortion. In the source, simply plug in our CG footage, and in the STmap, plug in our distortion image. For this to work correctly, we have to select our STmap node and set the correct UV channels, which is RGB. And in addition to that, we are right now also upscaling everything to 4K, since that distortion image is in 4K, so let's downscale everything. For this, we need a reformat node. And within it, we need to select 2K DCP, as this is actually the same resolution that our render is in, 2048 by 1080p. When doing this, Nuke has one huge advantage over Blender, which is that a single STmap node is enough to distort all of the AOVs. This means that we don't have to duplicate the STmap node for every single AOV we want to use. I'm not going to explain every single step that you need to take to recreate the setup in Blender, but I do want to show you what such a setup might look like. The purpose of the transform nodes is to center the distortion images that are exceptionally large. Note that both of these have to have the same values for this to work. But now, just like in Blender, I can control the distortion using a single slider.